So this is a question that was brought to me by one of my students in our recent tutoring sessions that she was stuck on, and I thought that this was a really good example of a typical type of potential divider question that you'll see in A-level. So I thought, let's go through it, see if we can find an answer, and hopefully teach you how to answer these sorts of questions. So to begin with, let's have a read. The question says, the battery in this circuit has an EMF of 4.2 volts, as you can see here, and negligible internal resistance. What are the readings on the voltmeter, so that's this voltmeter, when the switch is open and when the switch is closed? Okay, so first off, let's have a go at when the switch is open. So electricity will come out of the battery, flow down here. It has nowhere to go through this resistor because there isn't a complete circuit, so the electricity will just flow down here, straight through the voltmeter, into this parallel combination of resistors, and then back into the battery. There's no component before the voltmeter that we can have a voltage drop across, therefore the voltage at the voltmeter will be equal to the input voltage. So we know that the answer is going to be either B or D, so I'm going to put crosses next to A or C because we know those can't be the answers. It has to be 4.2. Okay, fantastic. Now for the next bit, we need to figure out what the voltage is going to be on the voltmeter when the switch is closed. Okay, so to make our lives a bit easier for this part, what we're going to do is we're going to figure out what the resistance of this parallel combination of resistors is, so that when we then try and tackle the next bit of the question, which is going to be treating this as a potential divider, it's a lot easier to understand. So let's have a go at doing that. To calculate the resistance of a parallel combination of resistors, that's the equation 1 over RT, or the total resistance, is equal to 1 over R1 plus 1 over R2, where R1 and R2 is the resistance of each of the resistors in the combination. Fantastic. So what do we get there? We get that 1 over RT is in this case equal to 1 over 40 plus 1 over 40, which gives us 2 over 40, or 1 over 20, and hopefully we can really easily see therefore that RT is going to be equal to 20. Brilliant. So let's redraw this electric circuit now with the information that we can model these two resistors in parallel as a single 20 ohm resistor in series with the rest of the circuit. So 4.2 volts still, coming round into a 10 ohm resistor, which I'm going to label R1, then into a 20 ohm resistor, R2, oh, don't forget to put the ohms on, and then back up and connect it again. And we have a voltmeter over our 10 ohm resistor. Fantastic. Okay, brilliant. Now, hopefully you can see here how we've replaced this nasty combination into just a single resistor here. And now this should hopefully remind you guys of a potential divider type setup where we've got two resistors of different values and input voltage, and now we know that we're going to have some sort of potential here which is proportional to the ratio between this resistor and the total resistance of the circuit. Now, some of you guys may have learnt that equation, however, I'm sure some of you may have forgotten it or prefer to learn based off derivations. So let's go through the derivation of how to get about this equation, and then we can shove out all of our numbers in at the end and get our answer. Okay, so to calculate the voltage across this 10 ohm resistor, which remember we called this R1, so we'll call this voltage V1, or the voltage across this resistor. V1 is equal to IR, as we know, Ohm's law. I is the current through the resistor, which we currently don't know. R is R1, the resistance of this resistor. Okay, so what do we need to know to calculate V1? Well, we currently don't know I, so we're going to have to try and find some way of calculating I for the circuit to therefore calculate the voltage drop. Fortunately, we've now got a series circuit, so the current at every point in this circuit is going to be equal. So what we can do is again use Ohm's law, except this time for the entire circuit, to calculate the current through the circuit at every point. So we have that V in, or the total voltage of the circuit, is going to be equal to I times by RT, which is the total resistance of the circuit. Okay, fantastic. Let's figure out then what RT is going to be. Well, we have that V in is going to be equal to I times by R1 plus R2 in this case, with two resistors. And rearranging for I, we get that I is equal to V in, or the input voltage, 4.2, divided by R1 plus R2. Fantastic. Okay, now our next step is to substitute this equation back in, because we've now got something which gives us the relationship of what I is. So substitute this back into our original equation, and what do we get? We now get that V1 is equal to V in times by R1 over R1 plus R2. Okay, and this is kind of where we get the term potential divider from. As you'll see, the input potential difference coming into the circuit is divided by the ratio of the value of our resistor to the total resistance of the circuit. And this is the equation for a potential divider. I'm sure some of you have learned it, but hopefully now you can see where the derivation comes from. So in our case, putting in our numbers, we have that V1 is going to be equal to 4.2, which in our case is the input voltage, times by the resistance of R1, which is 10, over R1 plus R2, which is 10 plus 20. Now this is going to be equal to 4.2 times by 10 over 30. Hopefully we can really easily see that 10 over 30 is just equal to a third. So it's 4.2 times by a third, which we will hopefully see coming to our answer, gives us a third of 4.2 is 1.4 volts. Fantastic. So let's triple check and see if that's one of the answers. Fortunately it is, 1.4 volts, 4.2 volts. So we can therefore see that D is going to be our answer. Unfortunately, checking the mark scheme, that is correct. That is our answer. So hopefully this gives you a bit of insight as to how we form and answer potential divider questions. This at least gives you hopefully a bit of insight into how it's derived. If you prefer to learn equations, you can just learn that this is the potential divider equation. But if you like to derive your own equations, that's the way that you do it. It all comes from this Ohm's law back here. All right, hopefully that helped you answer the question. And yeah, feel free to like, subscribe, and share with anyone else who you feel like this would be useful for to see more types of A-level, GCSE, math and physics questions.